The packet fragmentation reassembly subsystem manages the reconstruction of fragmented network packets at the transport layer. When a packet exceeds the maximum transmission unit of an underlying network interface, the system automatically segments the payload into smaller units, each with an identical fragmentation header. The reassembly process operates as a stateless finite machine that buffers incoming fragments until a complete datagram is recovered. Fragment ordering is determined by sequence identifiers embedded in the packet header. Fragmentation identifiers are assigned per datagram and incremented monotonically within a rolling 16-bit counter space. The identifier persists across all fragments belonging to a single datagram, allowing the reassembly engine to multiplex multiple in-flight datagrams concurrently. Fragment offset values indicate the position of each fragment's payload relative to the original datagram start, measured in 8-octet units. This granularity ensures efficient alignment with common word sizes in modern processors. The reassembly buffer maintains a per datagram state structure containing metadata such as the expected total length, arrival timestamp, and a bitmap indicating which fragment ranges have been received. Memory is allocated from a fixed size pool at system initialization. Once allocation occurs, the buffer persists until either reassembly completes or a configurable timeout expires. Default timeout is 15 seconds from the timestamp of the first fragment arrival. Fragment validation occurs at ingestion time. The system verifies that the offset and length fields do not exceed the declared datagram size, and that overlapping fragments possess identical payloads in overlapping regions. Fragments with mismatched payloads in overlapping areas trigger a validation error and are discarded. Fragments with offset values that would result in out-of-bounds memory writes are also dropped without further processing. The more fragments flag is a single bit in the fragmentation header that indicates whether additional fragments follow. When this flag is 0, the current fragment is the final segment of the datagram. The reassembly engine compares the offset plus length of the final fragment against the declared total datagram length. If these values match exactly, and all earlier offsets are contiguous with no gaps, the reassembly is complete. Upon successful reassembly, the complete datagram is transferred to the next processing stage and the buffer is returned to the free pool. The system maintains counters for successful reassemblies, incomplete reassemblies that timed out, and reassemblies that failed due to validation errors. These counters are updated atomically to allow safe, concurrent access from multiple kernel threads or network interrupt handlers without additional synchronization. The buffer pool is initialized with a fixed count of reassembly descriptors. The pool size is configurable at compile time via the kernel configuration parameter frag reassembly pool size. The default value is 256 descriptors. If all descriptors are in use when a new datagram begins to arrive, subsequent fragments are dropped and logged. The system does not perform allocation or eviction of existing reassemblies under high load. Timeout processing occurs in a periodic background task executed every 500 milliseconds. The task scans all active reassembly buffers and compares the current system time against the stored arrival timestamp. Buffers older than the timeout threshold are deallocated and returned to the free pool. Partial datagrams discarded due to timeout do not trigger the error counter. They increment a separate timeout counter instead. The fragmentation header consumes 8 octets of overhead per fragment. The first 4 octets store the fragmentation identifier, protocol number, and a reserved field set to 0. The next 2 octets contain the fragment offset in 8-octet units and the more fragments flag. The final 2 octets store the datagram total length. All multi-octet fields are encoded in network byte order, most significant octet first. Memory layout for reassembly buffers follows a fixed structure. The first 32 octets contain metadata, datagram length, fragment identifier, arrival timestamp, received bitmap, and state flags. Remaining space holds payload data, calculated as total buffer size minus 32 octets. Default buffer size is 2048 octets, supporting datagrams up to 2016 octets. The system does not support datagrams exceeding this configured maximum length. The received bitmap is a 256-bit field encoding which 8-octet blocks of the datagram have been received. Each bit corresponds to an 8-octet range. A bit value of 1 indicates that at least 1 octet of that range has been received. The bitmap allows efficient determination of gaps in the received data without scanning fragment lists. Bitmap updates are performed via atomic bit manipulation instructions where available. The state flags field contains single-bit status indicators for active reassembly, complete reassembly, timed out reassembly, and validation error. The active flag is set when the first fragment is received. The complete flag is set atomically when the final fragment completes the datagram. If either the timeout or error flag is set, the buffer cannot transition back to the active state and must be deallocated. Fragment ordering within the reassembly buffer is not guaranteed. The system processes fragments in the order they arrive and places each into the correct position in the output buffer based on its offset value. This design eliminates the need to sort fragments before copying payload data. Fragment data is copied to the output buffer position immediately upon validation, before checking completeness. The system maintains separate per-processor counters to minimize lock contention. Each processor writes to its own counter variables, avoiding synchronization overhead. Periodic aggregation sums all per-processor counters to produce global statistics. This design sacrifices instantaneous consistency for improved performance under high fragment processing rates. Counters are declared with volatile qualifier to prevent compiler optimization. Edge case handling includes datagrams with 0 total length, which are dropped during validation. Fragments with 0 payload length are accepted but do not contribute to reassembly progress. Datagrams declaring lengths that are not multiples of 8 octets are permitted, though the final fragment may be shorter than 8 octets. The fragment offset field granularity of 8 octets does not restrict datagram size or alignment. The reassembly subsystem integrates with the network stack at the interface between transport and link layers. Configuration parameters are established during kernel initialization and remain static thereafter. Runtime modification of timeout values or buffer pool size is not supported without kernel recompilation. Diagnostic information is available through standard kernel statistics interfaces and debugging symbol inspection.